Okay, so let's look at this next section. We're talking about absolute value equations, okay? And they ask us to solve. So here's the thing. You know when you take the absolute value of a number, you always get a positive answer. Is that correct? Do you know why? Okay, so you need to remember the definition of an absolute value. Absolute value actually represents the distance a number is from 0. So if you have positive 3, that's 3 units away from 0, isn't it? Well, if you have negative 3, that's also 3 units away from 0. That's why you always get a positive answer, because it represents a distance. Okay? Okay, so over here, problem number 1. They say the absolute value of y equals 10. Well, what number does y have to equal in order for this to be true? Yes, y could be equal to 2 numbers. Agreed? So it could be a positive 10 or y could be a negative 10. Is that agreed? So let me sidetrack you a second. So what's inside the absolute values could be a positive 10, or what's inside the absolute value could be a negative 10. Is that agreed? Okay. Now, there's actually 2 ways of working this problem out, writing the initial setup. I'm going to write it a little differently than the authors of the book that you're using, probably. Why? Because in another lecture, I'm going to do absolute value inequalities. And the inequalities are a little bit different than the equations. So, this y, right, could be a positive number. So I know that this y has to be equal to this positive 10, right? But if the y was negative, it also has to be equal to a positive 10. Don't you agree? Right? Because it's supposed to equal a positive 10. Yes? Okay. Which, this one is already solved. I know y equals 10. This one, when you solve it, you have to multiply both sides by a negative 1, and you know that this y is also equal to a negative 10. Do you agree? Okay, which we knew. It had to be a positive 10 or a negative 10. Agreed? Okay. As I mentioned, the way I'm setting this up is a little bit different than the authors of the book you're using. I'm sure they're probably a little bit different. But it has to do with another lecture that we're going to work on. That'll make more sense. So for the time being, let's look at problem number 2. I have this absolute value of 3x and it equals 12.6. Now, here's the deal. The number inside here could be a positive number, agreed? Or the number inside here could be a negative number. Do you agree? Yeah. One way or another, though, this 3x has to be a positive 12.6, or that has to be a negative inside of here, and it still equals the positive 12.6, right? Okay, so that would mean that we would have our positive 3x equals to 12.6. But this 3x inside here could also be a negative 3x, right? And when you take its absolute value, it's still a positive 12.6, isn't it? Okay, so this one, when I solve, what do you get? Yeah, you divide both sides by 3, you end up with 4.2, don't you? This one, what do you think you should do first? Good. Divide both sides by the negative, probably be a little bit easier. So I'll have 3x equals to the negative 12.6. Then I divide both sides by 3, and I end up with x equaling a negative 4.2. Cool? Okay. So now, in these 2 problems, I had the exact same answer except one positive, one negative, right? Yeah, that doesn't always happen. Stay tuned. I'll be right back. Okay, so let's look at problem number 3. So keep in mind on problem number 3, what are we solving for? Good, we're solving for n. So I need to get everything away from the n, correct? Well, do you notice the n is in absolute values? So everything that's not in the absolute value needs to move over. Do you agree? Okay, so that 5 is not in the absolute value, is it? And it's on the same side as the n, correct? So what do we have to move first? Good, we have to move that 5 first. Now, here's the deal. If you're a visual person and you need to put this minus 5 on both sides, then please make certain you put that minus 5 on both sides so you can visually see what you're doing. I may not always do it, but you better do it for yourself. Got it? Okay, so that leaves me the absolute value of 3n equaling 9. Good. Now, the n is inside the absolute values, isn't it? Okay, so here's the deal. You may have noticed it, you may have not noticed it from the last two problems, but I just can't get to the n because of the absolute value signs. The absolute value signs act like a wall, and nothing gets through the wall. Are you with me? I don't care how good of a sledgehammer you have, nothing gets through this wall. So I need to think, okay, well this 3n inside here needs to be what number? Yeah, it needs to be a positive 9, right? Because then when I take the absolute value of it, I get 9. But this number inside here could also be negative, couldn't it? And it still equals a positive 9, doesn't it? Okay, so here's the deal. That means you're going to have how many equations? Good, 2. Just like the last two problems, we ended up with 2 equations, didn't we? Okay, so in this case, I know that the number inside is a positive, so there's my positive 3n, and when I take its absolute value, it should equal a 9. Agreed? But I also know that the number inside the absolute values could be negative. And then when I take the absolute value, it's still supposed to equal a positive 9. Agreed? Okay, so let's solve. Here, good, divide both sides by 3, so I get n equals 3. There's one answer. What are we going to do here first? Yeah, my recommendation is move that negative over by multiplying or dividing by a negative, so I end up with 3n equaling a negative 9. And then when I solve for n, you're still going to, good, divide both sides by 3, and I'll end up with n equaling a negative 3. Cool? Okay, so let's look at problem number 4. Problem number 4, I'm still solving for n, and it's inside the absolute value, isn't it? Is there anything outside the absolute value on the same side of it? On number 3, I had that 5, so I had to move the 5 over first, didn't I? Do I have anything like that here? No. So here, I can break it into 2 equations right away. On number 3, I couldn't break it into 2 equations right away. I had to move the 5 over, and once the 5 was moved over, then I could break it into 2 equations. Are you with me? Okay. So, since the absolute value is by itself, I can break it into 2 equations right away. Pause the recording, make that note to yourself. When the absolute value is by itself, you can break it into 2 equations right away. Okay, so now, inside here, right? And by the way, humor me a second. I'm going to write it this way because some of you are visual and you need to see what I'm saying. This is a positive number inside here, and it's supposed to equal 4. But I'm also supposed to have the negative, right? So the negative of the number inside, when I take its absolute value, is still supposed to equal a positive 4. Are you with me? Okay. Do you need this positive? No. But because this is an addition problem here, I kind of wanted you to see it that way. You with me? All right, so here, positive sign isn't going to change anything. I still have n over 3 plus 2 equaling 4. And then minus the 2 on both sides, good. And then, good, multiply both sides by 3 because you got to get rid of that denominator over 3, which means you have n equaling 2, 6. Excellent. Now, let's look at this one over here. Do you notice that negative out front? Yeah, do you want to keep it there? Neither do I. So here's my suggestion. My suggestion is to divide both sides by this negative. And when I do, I still have n over 3 plus 2, but now equals a negative 4. Got it? And then, minus 2 from both sides, excellent. Gives me a negative 6, and then, good, multiply both sides by 3, and I get negative 18. So, as I mentioned a couple minutes ago, Sometimes it looks like you get the exact same answer, but just one positive and one negative. But you don't always get the same answer, one positive and one negative. This is a 6. This is a negative 18, right? This may be a positive and negative 3, but that doesn't always happen. This one shows that. Got it? Okay, so hang in there. Got a couple more problems for us to work. Okay, so let's look at problem number 5. So in problem number 5, do you see the absolute values? Good. So, how many equations am I supposed to have? Good, 2 equations. Now, here's my question. Am I able to break it into 2 equations right now? For problem number 5, are you able to break it into 2 equations right now? Some of you said yes, some of you said no, some of you are like, I don't know. So hear what I have to say, pause the video, write it down, and then start again. You can only break it into 2 equations when the absolute values are by themselves. Again, you can only break it into 2 equations once the absolute values are by themselves. Just like we did the last 4 problems. Once the absolute value was by itself, then we could break it into 2 equations. Got it? Okay, so can I break this into 2 equations right now? Good, no. Why? Excellent, you got to move over that minus 10. And how do I move over the minus 10? Yes, you add 10 to both sides, which means the real problem I'm working on is the absolute value of 4n minus 1 is equal to 14. Okay, so the absolute value is by itself. Can I break it into 2 equations yet? Yes, you can. Excellent. So remember, I have the positive of this is supposed to equal 14, but that number inside could also be negative, and when you take its absolute value, it's still supposed to equal a positive 14. With me? Okay, so let's solve it. That positive doesn't do anything, so I have 4n minus 1 equals 14. Then what? Good, add 1 to both sides. Gives you 15, excellent. Then what? Good, divide both sides by 4, which gives you 15 over 4. And if they don't ask for a decimal or a mixed number, you leave it alone. Got it? But question, can I reduce 15 over 4? No, so I'm leaving that as my final answer, at least for that problem. Okay, let's look at the second equation we wrote. Do you want to leave that negative sign there? Yeah, neither do I. So I'm going to divide both sides by the negative first, which is going to give me 4n minus 1 equaling negative 14. And then what are you going to do? Good, you're going to add 1 to both sides, which gives you negative 13. And then what are you going to do? Good, divide both sides by n, which gives you a negative 13 over 4. Cool? Can you reduce that fraction? Nope, then I'm leaving it alone. Got it? By the way, you know, we kind of skip this step because we're so used to solving equations and we're very secure in our abilities to solve. But how do you know these answers are right? Yeah, you would have to take each one of them individually and plug them in and make sure they worked. Correct? And then plug this one in, make sure it worked. Correct? Okay, just checking. Just making sure you remember that. Okay, let's look at number 6. Okay, absolute values are there. Good. Can I break it into 2 equations right now? Yay! You said yes, I heard you. Why? Because the absolute values are by themselves. So that means I can break it into 2 equations right away. Excellent. Good job, you guys. Which means one of my equations would be, good, that number inside here could be the positive, right? And it equals 7. But this number inside could also be a negative, because when I take its absolute value, it will still be a positive 7, won't it? Okay, so here, yeah, that positive isn't going to do anything. What are you going to do to get that x by itself? Good, minus the 7 over, so I have negative 3x equaling what? 0. Yeah, and then, Divide both sides by -3, which means x equals 0. Good. Let's look at that second equation you set up. Okay, so you want to leave that negative there? Neither do I, so I'm going to move it over, and I'm going to divide both sides by a negative or multiply both sides by the negative. So on the right side, I end up with a -7, don't I? Excellent. And then what? Good, -7 from both sides, so you have -3x equaling what? Yeah, -14. And then what are you going to do? Divide both sides by -3, which gives you, yeah, you get a fraction, and it doesn't reduce, I know, but you have a -14 divided by a -3, which is a +14 over 3. Cool? Does this make sense? Okay, so again, how do I know these answers are correct? I plug them in. When I take the 0 and plug it in, I better get the absolute value of this number equaling a +7. And when I take the 14/3 and plug it in, I better get the absolute value of this number equaling a +7. Does that make sense? Okay, so you know what, on this problem I'm going to check them. I'm going to show you because some of you get what I'm saying and some of you are like, I'm visual, I need to see it. All right, so I understand. So for this one, x equaling 0, I would have the absolute value of 7 minus 3 times 0, wouldn't I? Equaling 7. Well, inside the absolute values, what's 3 times 0? 0. What's 7 minus 0? 7. Right? Now here's the thing. We set this one up as the number inside here being the +7. And it does. It is the +7. So I have 7 equals 7. Good? Let's check the second one over here. So I'll have 7 minus 3 times 14 over 3 equaling 7. Okay, 3 times 14 over 3, what's going to happen here? Good, those 3's are going to cancel, which gives me 7 minus 14 inside the absolute values, right? Well, what's 7 minus 14? Good, a -7. Now, mind you, this equation we set up so that the number inside was negative. And we did. We got a -7. But it's inside absolute values. And so, absolute value of -7 is 7, which equals 7. So this one checks out also. Yay! But do you see what I mean by the check? When I plugged in the 0, I ended up with the +7 inside the absolute values, because that's how I set up the problem, for it to be the positive. And when I plugged in the 14/3, I ended up with the -7 inside the absolute values, because that's how I set this equation up, to be the negative inside the absolute value. Got it? Okay, stay tuned. Got a couple more problems for us. Okay, so let's look at problem number 7. So it says the absolute value of 5x minus 1 equals 0. So, how many equations am I supposed to have? Good, 2. Can I break it into 2 equations right now? Yes, I can. Excellent, because the absolute value is by itself, so I can break it into 2 equations right now. So, one of those equations would be the positive, right, of 5x minus 1 equaling 0, wouldn't it? The other one would be the negative number, wouldn't it, of 5x minus 1 equals 0. Correct? Okay, well, the positive doesn't change anything, does it? So now what? Add 1 to both sides. Now what? Divide by 5. Yep, you end up with a fraction. Good? Okay, what about this one? Yeah, divide both sides by the negative, so you end up with 5x minus 1 equaling, well, 0 divided by a -1 is still 0, isn't it? Well, isn't that the exact same equation as this one over here? So am I going to get a different answer? No, why would I get a different answer? Okay, so here's the deal. When you have the absolute value, when it's by itself and when it equals to 0, in actuality, you don't end up with 2 equations. In actuality, you end up with 1 equation. And that one equation is the number, the expression inside equaling 0. So I just had 5x minus 1 equals 0. Good? Cool. This is one of the exceptions to the rules. Usually we end up with two answers, but when the absolute value by itself equals 0, I only get one answer. Good? Okay, let's look at this one. So I have an absolute value here. Can I break it into two equations? Nope. Good. Why not? It's not by itself. On the same side of the absolute value, on the same side as the absolute value, is this plus 4. So what are you going to do? Yeah, you're going to minus the 4 to the other side first. So when you do that, you end up with the absolute value of x plus 4 equaling -3. Excellent. Then what? Good. Break it into two equations, right? You're going to have the positive of the x plus 4 equaling -3, and you're going to have the negative of the x plus 4 equaling -3, aren't you? Okay, so let's solve. The plus sign doesn't change anything. This is still x plus 4 equaling -3, and then minus 4 from both sides, you get -7, don't you? Here, what are you going to do with that negative? You going to leave it? Yeah, move it to the other side. So I end up with x plus 4 equaling a +3, don't I? And when you solve for x, you end up with x being a -1, don't you? And you're like, yay, two answers like I'm supposed to get. And I'm going to tell you on this problem, you better check your answer. Watch. Just watch. Some of you are like, why? Just watch. I'm going to check this -7. So I'm going to start it over here so I can have some room to work. All right? So here's my check I'm going to start. We have the absolute value of -7 plus 4 inside the absolute value signs, right? Plus the 4 equals 1. Well, inside the absolute value is going to be a what? Good, -3 plus 4 equaling 1. And then, yeah, absolute value of -3 is just 3, right? Plus 4 equaling 1. I have 7 equals 1. Does that answer check? Nope. Uh-oh. Let's check this one. So this one didn't check. Let's check the other one. I have the absolute value of -1 plus 4 plus that 4 equaling 1, correct? Okay, so inside here would be a +3 plus 4 equaling 1. Well, what's the absolute value of 3? 3, so I have 3 plus 4 equaling 1. I have 7 equals 1. Wait, that's not true. Wait, this doesn't work either? You're like, what the heck's going on here? Two answers and neither one of them worked? I did everything correctly. Yes, you did everything correctly. However, when you got the absolute values by itself, when you got that absolute value by itself, you ended up with the absolute value equaling a negative number. Absolute values always give you what kind of number? A positive number. So you're trying to make a positive number equaling a negative number. Does that happen? Can you ever have a positive number equaling a negative number? Nope, you can't. You could have stopped the problem right here. When we got this line right here, you could have stopped and said, oh, this isn't working. I don't care what answers I get, they're not going to check. You could have stopped right here and said that the answer is no solution. Because there is no way you are going to get a positive number equaling a negative number. Because you're going to end up with something that's false on both answers that you get. Got it? Yeah, be careful of that one. Stay tuned, I got one more example for us. Okay, so let's look at this last problem. Do you notice I have an absolute value on both sides? You're like, well, what's that about? Okay. The only reason I actually have an absolute value on both sides because I have a variable on both sides. I've got the y on the left and the y on the right. So I actually have a variable on both sides, which is why there's an absolute value on both sides. Got it? You're like, okay, so how do I handle this problem? We handle this problem the exact same way we've handled the last 9 problems, or pardon me, the last 8 problems. Okay? Exactly the same as the last 8 problems. So, here's the deal. In this case, I have a choice of which side I'm going to make the positive and the negative. I'm going to keep it the same way I've been keeping it. This is the side I've always made the positive and the negative because this is the side that had the absolute values on it for the last 8 problems. So I'm not going to change the way I do things. So here's the deal. We have the positive of the 9y plus 1 must equal the 6y plus 4, or we're going to have the negative of the 9y plus 1 equaling the 6y plus 4. Exact same process. With me? Nothing is going to change. Just because there's an absolute value on both sides doesn't mean I change my process. Cool? Okay, so let's go solve this one over here on the left. The positive sign isn't going to change anything. I still have 9y plus 1 equaling 6y plus 4. I'm going to get all my y's on the same side. Which side do you want them on? The left? Okay. So, good. Subtract the 6y on both sides. That leaves me 3y plus 1 equals 4. Then what? Minus the 1 on both sides. Leaves you 3y equaling 3. Then divide both sides by 3. So on this equation, I get y equals 1. Cool? Okay, let's look at this one. Now on this one, what we have typically done is we have divided both sides by the negative 1, or multiplied both sides by the negative 1. And I still can do the exact same thing that I did on the last 8 problems. I can divide or multiply both sides by the negative 1. Now here's the reason that we really did that, is we didn't want to deal with the variable being negative. Well, here's the deal. The variable's on the other side also. So us moving that negative sign over isn't really going to do anything for us. It really isn't going to make the problem any simpler for us to deal with. Cool? Okay, so in this case, I'm just going to leave it alone. And I'm going to get a negative 9y minus 1 equals that 6y plus 4. Then what? Put the y's on the same side, so good. You guys want to put them on the left, so I'm going to minus 6y, which in this case gives me a negative 15y, minus 1 equaling 4, correct? Then what? Good. Add the 1 to both sides, which is going to give you 5, right? Are we agreeable? In agreement, I should say? And then, yeah, divide both sides by the negative 15. Now, here's what I recommend. In this case especially, I recommend literally writing that down. Divide both sides by a negative 15. Because our brains sometimes would rather not deal with fractions, it may actually give you the wrong answer. What do I get here? Yeah, I get a negative 1/3. How many of you saw that line and literally said, oh, 3? Yeah, that's why if you said 3 or negative 3, I recommend you put this divided by negative 15 on both sides so you can see the answer as a fraction, a negative 1/3. Does that make sense? Okay, so solving these absolute value equations isn't so bad, really, is it? Always get the absolute values by themselves and then break it into 2 equations. 99% of the time it breaks into 2 equations. The 1%er is like problem number 7 we did just a couple of minutes ago. And then you got to be careful of problems like number 8 where it's actually equal to a negative number, because that doesn't give me a solution at all, does it? Okay, you guys have fun with this stuff, and I'll catch you on the flip side.